This is video 3 of categorical data analysis. This is a short video learning chi-square distribution. First, we use the notation of Greek letter chi and square of chi with degrees of freedom n. Theoretically, chi-square distribution is the sum of many squared standard normal distribution. If it's where chi-square came from. If we take a square of the number of standard normal variable z's and add them up, it will look like the graph on the right-hand side. It is mostly right-skewed, but depending on how many we are adding up, the shape of the curve changes. When degrees of freedom is 1, which means just one squared standard normal distribution, it looks like a blue line with the degrees of freedom 1. As degrees of freedom increases, the curve becomes more symmetric, approaching a normal distribution. We can generate the similar graph using our own code, our code here. So first graph, the first coding, the code chunk and the graph is chi-square distribution with 1 degree of freedom. Here we are generating a random numbers from standard normal distribution using our norm function and draw a histogram of squared value of those random variables. So we take the square and want to see what's the distribution of it. So we draw a histogram to see the distribution. We see the histogram is very right skewed, similar to the graph in the previous slide with degrees of freedom 1. At the bottom code, we generate a whole bunch of standard normal distribution and draw a histogram of the sum of those squared random numbers. It looks a little bit complicated, but you don't actually need to worry about it. The point is here, n is the degrees of freedom. And if you copy and paste this code and change n to 1, 2, 3, up to 10 or more, you should be able to see the shape change of the histogram. In this particular graph with the degrees of freedom 10, we can see the shape of the curve is more symmetric and getting close to normal distribution, although it is still slightly right-skewed. Try various different n on your own and see what happened to the shape of the distribution.